Okay, so now I want to talk a bit about the point slope form. So if you're given a point and a slope, how do you find the equation of a line? Now, old, so this is old and new. So your old, and the textbook shows something like this: y minus y1 equals m times x minus x1. Okay, so we have that. Well, that's fine, you can remember that. But new, what I want you to think of is y equals, and we can still go with the y1 plus m times x minus x1. Now, as we think of function notation, though, what I want you to think of here, and again, this is true for straight line functions. Other functions, it's only sort of true. Okay, it's true if you keep x1 really close to the x that you're interested in, and so here, though, you going to that function notation, f of x equals f at x1 plus m times x minus x1. Okay, so what this says is that, sort of a way to view this is, right, here's x, there's y, or f of x. Now, for straight line functions, this is absolutely true. This works out just like with the straight lines because that's what you're working with. But as you read this, you can think of it as you are starting here. Here's x1 and here's y1 equals f at x1. And so you're at this point. And it says that if I want the value of f of x at any other x value, right, all I have to do is start here and then use notice this is a change in x or y sort of thing, all right? This is looking like m times delta x, right? And so if I want to go out here to this x to find that f of x, you see, you can think of it as starting here and then doing that change in x to there multiplied by the slope, then gives me that change. So there's the change in f of x that I needed to get to there. And think of that formula sort of that way, is that I'm kind of starting at this one spot, and then I'm using that change formula. So you see this is kind of a fx1 plus my change in f. Okay, or up here it's my y1 plus not m times, just the change in y. Okay, so you can think of that point slope form that way, and here I even, I'm writing it as, hey, this is where I'm starting. I'm starting in these places, and then to get my new value, I just need the change from there. But how do I get that change? Oh, from the slope and how far over I'm moving in x here. Okay, so that's the new form that I'd like you to begin to embrace. I will tend to use this form instead of doing the y minus y1. I'll do either y equals y1 plus m times x minus x1, or I will do an f of x equals f of x1 plus m times x minus x1. And this change, I don't do it for, no reason at all. Actually, it's to help us better understand what we're doing with calculus. Okay, so if we better understand what these relationships are telling us, it makes calculus a lot easier, and it also makes it much more powerful, because what we want to do is be able to understand what we're doing. We want to be able to interpret what these symbols mean, and use this symbolic language to help us do calculations. But actually, a lot of the understanding and interpretation are coming from this graphical language down here. So we have our human language, right, our English and so forth. Then we have graphical language like this that we understand very well visually. We tend to be very good visually. Then there's this algebraic language, okay, this symbolic language up here. Well, that turns out to be great for pushing the envelope of our understanding and our theory, and doing calculations, that sort of thing. And so, we want that algebraic symbolic language, but just like any kind of language, it can be very helpful in how you use that language and how you represent things within that language. And so here, instead of representing a particular idea this way in the language, we're going to spend our time representing it this way within the language. And the idea is that if we represent it this way within the language, we can then better understand it or internalize it better within our mind and hey, within our hearts. How about that? But that is what I wanted to mention for the point-slope form. And so I think we're done with that. Is just, let's start using this other way to write the point-slope form.